Hi and welcome to the walk and talk run through of the Pearson Edexcel paper 3 non-calculator. Yeah, just checking through again. We can see it's a calculator paper. Key thing, diagrams are not drawn accurately unless told otherwise. Showing all your working means to show you're working in a calculation. For instance, like 38 times 15. You don't have to do a column method, put it into the calculator and then put your answer, but make sure you've written down what you've typed into the calculator to show the examiner this. Okay, so let's go straight in. Question 1, 45% as a decimal. Okay, again in relation to this question, you can just type in 45 shift and the percentage key, and that will give you a simplified version of 9/20. You could start that off as 45/100. That would also be correct. Okay, if it was needed in fraction form, just like that one would be. Okay, but we need it as a decimal. So if you press SD, both answers will come back to the same decimal, being 0.45. Okay, so you can put the same thing into the calculator. This time we're going to press the SD button and my answer would be 0.45. Okay, if we're looking at question 2, write down 2 factors of 35. So if we think 35, if we broke this into a factor tree, okay, we've got 1 times 35, 2 doesn't go into it, 3 doesn't go into it, 4 doesn't, 5 does 7 times, and we just want 2 of those factors. So you could put any of those 2, for instance 5 and 7. We've also got 1 and 35. So any 2 from that group of 4 will do. You could do different pairs of factors like we've got there. Alternatively, if you wanted to, you could put 5 and 35. Okay, it doesn't ask for a pair of factors, just any 2 factors. So maybe 5 and 7 is the best to go for here. Question 3. What is the time 2 hours and 40 minutes after 8:05? Now my advice with this one is split it down in the sense of do the hours first. So I'm going to plus 2 hours to that, 8, 9, 10. Okay, and then I'm going to put 40 minutes to that. So 5 past the hour, add another 40 minutes, gives me 45 past, or a quarter to 11. So 10:45 AM would be my time. Be careful if that was, for instance, let's say that was 25, 8:25. We could do the same method, adding the 2 that side gets me to the 10. But adding 40 this side, add it straight on, gets me to 65. Remember, I can't go over 60 minutes. That becomes another hour. So I would have to move that forward, and it would be 11:05 if that was the case. So take care if that is the type of question that comes up. But on this one, 10 hours, 45 minutes. So 10:45 AM. Question 4. 1/6 of 66. Okay, that's like saying 1/6 of is times 66 over 1 is another way of saying that. So 1 times 66 gives me 66. 6 times 1 gives me 6. And how many 6's go into 66? My answer would be 11. Okay. The other way you could think about this, here's 66. Cut it into 6 equal pieces. Okay, how much would go into each of this? So I'm still doing the same fraction, 66 divided by 6. And there would be 11 in each section. Okay, so it's perfectly fine to visualize it in that format if you wanted to. Question 5. AB is a straight line. Okay, mark with a cross the midpoint of AB. Okay, now again, it's very difficult to do this without a ruler, but just to show you a really simplified way. I'm going to get a piece of paper. Okay, and I'm just going to mark on it where that line goes to. So that's the length of my line. Okay. So I've taken my piece of paper. That's the length of the line. Fold it in half. Now, if you had a ruler, what you would do is you would mark the halfway point, measure it, divide it by 2, and you would find the halfway point, which is just there. Okay. Now, the leeway you've got on a question like this, the amount of variance would be in that sort of range there. So you've got about that sort of range in relation to the 2 red dots. As long as you're somewhere between that mark, you'll be absolutely fine. Okay. And again, just to confirm, midpoint, middle of the line. Question 6a. Okay, we're multiplying these together, so they're all going to combine. Okay, if I've got a plus or a minus with different variables, then what they would do is they would stay separated. So on this one, A times B, the 2 letters will just squeeze together and become AB. Okay, and then I've got 4 lots of whatever that is, so that's going to give me 4AB. Right, on to B. Now I've got 4x and I've got minus 1x. So if I've got my bowl and I put 4 x's in there, and now I take an x away, okay, I've now only got 3 x's left. And I've got 3, add 5, gives me 8. So separate bowl, I've got 3 plus 5 in that one, and that's going to give me 8. So my answer, 3x plus 8. Okay, notice 2 marks on this one. 1 mark for your x terms, 1 mark for your number terms. Question 7. There are 3 cards in bag A. There are 2 cards in bag B. There is a letter on each of the cards. James takes a card from bag A and then a card from bag B. List all the possible outcomes. So it's just about being logical when you're doing this. Okay, so we could have E and J. We could have E and K. We could have G and J. We could have G and K. We could have F and J. We could have F, K. And that's all my possibilities. So we've got 3 in this one. We've got 2 in this one. So we should have 6 combinations, which we've got EJ, EK, GJ, GK, FJ, FK. Question 8. On Monday, Sandy pays for 2 plane tickets, 7 nights in a hotel, and 2 theme park tickets. Okay, show that Sandy pays more than $2,500 on Monday. So, 2 plane tickets. Well, each plane ticket is $600 times that by 2 is going to give me $1,200. 7 nights in a hotel. Each night in a hotel is $120. So we're going to times that by 7. So that's going to give me $840. And then 2 theme park tickets, and each ticket is $250. So that's going to give me $500. So adding those together, $1,200 plus $840 plus $500 gives me £2,540. Okay, so we've proved that that's more than £2,500 dollars. Sorry, dollars. So that's answered the question. Question 9. So we're going to do this a line at a time, working through each individual line of information. So Vadim has 56 clocks. So in total we have 56. The clocks are only red, only blue, or only black. Okay, so only each of those colours at the top, red, blue, black. It says 32 clocks are plastic, so we know that's going to be 32. Okay, 5 of the 14 blue clocks are plastic, so 5 of the 14 blue clocks are plastic, and 8 of the 12 red clocks are not plastic. 8 of the 12 red clocks are not plastic. Now, if we've got 3 things that we don't know, we can't solve it. If we've got 2 things we don't know, like red and black, we can't solve it. So we only can solve things where we've just got one space, like we can solve that one, we can solve that one, we can solve that one. That's my starting point. So 8 take away from 12 is going to give me 4. 5 take away from 14 is going to give me 9. 32 take away from 56 is going to give me 24. And now I can start to work out how many black clocks we've got. We know the total is going to be 12 plus 14 gives me 26. 26 away from that, 56 is going to give me 30. 8 and 9 gives me 17. 17 taken away from 24 is going to give me 7. And then just check the next one. We've got 5 plus 9, plus 4 gives me 9. 9 taken away from 32 gives me 23. And 23 added to 7 gives me 30. So we've used the information in the table to complete the two-way table. Okay. Question 10. Karina had £300 to spend on books. Each book cost £4.85. Work out the greatest number of books Karina could buy. All we're doing, okay, it's a three mark question. So we've got 300 divided by £4.85 equals. So that's what I'm going to put in my calculator. 300 divided by £4.85 is going to give me 61.8556701. So we can buy 61 books. So we're looking to truncate this number. Okay, so we're going to cut it off where it is. We're not going to round it up because we haven't got enough money to buy a 60-second book. So we can buy 61 books. Okay. And that would be my answer. So again, straightforward calculation. This time I'm dividing 300 by £4.85. And whether you write it in a fraction form like that, or you did it 300 divided by 4.85, it's still going to give you the same answer. And that would get you the marks for the working. Question 11. 11a. Write 196 minutes in hours and minutes. Now, even though it's a calculator question, what I would do on this one is I would break it down in the format of, well, if I take 60 away from that, I've got 136. That's 1 hour. If I take 60 away again, I've got 76. That's 2 hours. If I take 60 away from that, I've got 16. That's 3 hours. So I've got 1, 2, 3 hours, and I've got 16 minutes. So on certain questions, it may be easier to work through it manually like that in a logical sense. The reason being, if you said I've got 196 divided by 60, okay, your answer will be 3.26 with a recurring over it. Okay, it's very easy to put 3 hours, 26 minutes. That would be wrong. It isn't 3 hours, 26 minutes. Okay, I've only got 16 minutes left, but 16 minutes is 0.26 of an hour. Okay, so that's the mistake they want you to make by using a calculator on this one. So anytime you're in hours and minutes, it may be worth manually doing it like I've just shown there. A train travels X miles in 2 hours. We don't know how far it's traveling. So because we're talking miles, hours, we're talking speed, distance, time. Okay, write down an expression in terms of X for the average speed of the train. So if I wanted to find the speed of the train, cover that one up. What am I left with? I'm left with distance divided by time. So my distance is X miles. So X divided by how much times? 2. and that's going to be my speed. My speed is going to equal x divided by 2. Okay, and that's all I'm going to leave that as. So all I've done is I've taken the speed, distance, time triangle, and I've just substituted the distance in x miles. Okay. Question 12. The diagram shows 2 places on a map. There's Shelton and there's Trilby. The scale is 1 centimetre represents 20 kilometres. Okay, what is the actual distance in kilometres from Shelby to Trilby? Okay, and again on this one, it's difficult to do because I haven't got the capabilities on here to use a ruler. Okay, so all you're going to look to do is measure that value and then write down the amount of kilometers. Okay, so I'm just going to put this to okay. So let's say that's the size of it, 100%. So we're going to measure that value there. Okay, let's say that that's 5 centimeters long. So when I calculate this, this question may not be the correct answer for the paper. But if we say 5 centimeters long, what we'll do is we'll take our 5 centimeters and we're going to times it by 20 kilometers. Okay, so if it's 5, we times it by 20, that's going to give me 100 kilometers. So if your measurement was 6 centimeters, it would be 120. If it was 7 centimeters, it would be 140. 4 centimeters, it would be 80, and so on. So it's going to be the multiplication of 20 by whatever calculation you've found. Okay. On B, relates to the same thing. Okay, this says the scale was 1 centimeter to 20 kilometers. On a scale drawing, the scale is given as 1 to 1,200. Okay, how many meters does 5 centimeters represent on this drawing? Okay, so 5 centimeters. Well, if we're in centimeters, we've got no determination at the top there. This one was 1 centimeter compared to 20 kilometers. Okay, this one, they're both the same value. Okay, it doesn't say centimeters, it doesn't say kilometers, but they are both the same value. So coming down here, if one is 5 this side, all I'm going to do is I'm going to multiply 1,200 by 5. Okay, which is going to give me 6,000. So it would be 6,000 centimeters. Okay. Remember, look at that. There's another place they're trying to trip you up. We're in centimeters. They want it in meters. So I now need to convert 6,000 centimeters into meters. Remember, 1 centimeter, 1 meter is equal to 100 centimeters. So 1 meter is equal to 100 centimeters. So I need to divide 6,000 by 100. So that's going to give me 60 meters. And that's my answer. So first step for the first mark, I need to multiply 1,200 by 5 to give me 6,000. Remember, that's centimeters. And then I need to convert from centimeters to meters. So 60 meters is equivalent to 6,000 centimeters. Question 13. In the northern hemisphere, the ratio of the area of land to the area of water is 2 to 3. Okay, so I'm just going to write that down. And that's the area of land to the area of water. Work out what percentage of the area of the northern hemisphere is land. Okay, so I want it as a percentage. and I've got 5 parts in total. Okay, so if I take 100% and I divide that by 5, 1 part, okay, is equal to 20%. So land, I'm going to multiply it by 20, is 40%, and water is 60%. It wants to know what percentage of the area is land. Land is this left-hand side, so it's going to be 40%. Question B relates to the same question. Okay, 20% of the area of the southern hemisphere is land. Work out the ratio of the area of land to the area of water in the southern hemisphere. So we're taking this question and we're working backwards. Okay, so we're told that land is 20%, whereas water we know is 80%. Okay, so we need to work that back into a ratio, right? So we could put 20 to 80. That is a ratio. But if we try and do that in its simplest form, okay, if I divide that by 10, that's going to give me 2. Divide that by 10 is going to give me 8. And then I could half it. Divide by 2. Divide by 2 gives me 1 to 4. So my ratio in its simplest form would be 1 to 4. And remember, we're still doing area of land to the area of water, land to water. Okay, it's very important that you actually get the ratio in the right order from the question. That's going to come first, that's going to come second. Okay, so that's a very important thing to get. Right. Question 14. A stadium costs £600 million. 13/15 of this cost was for the building. The rest of the cost was for the land. Work out the cost of the land. Okay, so anytime I've got a fraction, remember this was a building, and we want the amount of money for the land. So we want 2/15. If you think 15/15, if we take away 13/15, is going to give me 2/15 left. So that's the cost of the land. So we want to know what is 2/15 of 600 million. So 2/15 of 600 million. And that's what I'm going to put into my calculator. So fraction key 2/15, tab to the right, times 600 million. And that's going to give me 80 million. Now I could type in the whole digits here, but if we look at my value, I want it in millions. So the calculation I'll put into my calculator is slightly simplified in relation to 2/15 of 600, because we're keeping it in the value of millions. Okay, so 80 million is the cost of the land. Question 15. Jenna measures all the angles around a point. So let's just draw. We've got 1, 2, 3, 4. 1, 2, 3. Let's make another one in here, 4. So we've got 4 different angles. So we're just going to put them random angles in there. It doesn't matter where they go. Let's put 145 there. Let's put 23 there. Let's put 23 there. And let's put 69 there. Okay, explain why these results cannot be true. So if we're just going to add them up, that should sum to 360. So I'm going to do 145 plus 23 plus 23 plus 69 equals 260. Well, it cannot be true because 360 does not equal 260. And there's 360 degrees in a full turn. Okay, now again, that's only a 1 mark question, so think of the workings there. We've got to add it all together to find that it's 260, and then we're saying that it doesn't equal 360, so it cannot be true. Okay, So we need to know that rule there, that there's 360 degrees in a full turn, and it doesn't equal 360 degrees. Question 16. Zoom out a little. Okay. So here is the diagram showing triangle ABC and triangle ADE. So ABC is this one here, and ADE is the bigger triangle. Okay. Describe fully the single transformation that maps triangle ABC onto triangle ADE. So what we're going to think is, firstly, is it the same size? Okay. If it's not the same size, it can only be one enlargement, one transformation, which it's been enlarged, or it's been negatively enlarged where it shrinks in size. Okay. If you have a decimal enlargement, if it was 0.5, it's going to be half the size that it was. So if it's a change in size, okay, then it's going to be an enlargement of some description. Okay, the two more things we need to know is how big is the enlargement. So this is one square. My bigger triangle, sorry, is 1, 2, 3, 4 squares. So it's gone from 1 to 4. How do I get there multiplication wise? I'm timesing it by 4. So it's been an enlargement by scale factor of 4. And we need to know where it's been enlarged from. Okay. If it's overlaid and that point is exactly the same, the corner is in exactly the same place, that's my point of enlargement. So the point of enlargement is 1, 1. 1 along the corridor, 1 up the stairs. Okay, and it's been enlarged from that point. Okay, very often you'll get something where they have an enlargement and they'll do the little triangle down here. And you can see the points are not in the same place, the corners of the triangle. So we'd have to see how far away that would actually be and try and work that one out. So this is a slightly easier question than some of the ones that they will give you. All right, so we need 3 pieces of information. We need to know the enlargement. Is it an enlargement? Yes, it is. It's got bigger. How much bigger has it got? Scale factor of 4. And where has it been enlarged from? And that's from that point just there. Okay. Question 17. So we've got 3 algebraic sums to be able to do. So expand just means to times out. Again, I can't use the calculator for this because it doesn't do it alphanumerically. We can't put letters into it. So y times y is going to give me y squared. Y times 5 is going to give me 5y. Okay. Factorize means to put brackets in, so take out a common factor. So what goes into 4 and 6, or 2 goes into both. So let's put the 2 outside. There isn't a common letter this time. There is only numerical factors. So if I take 2 out of there, 2 goes into 4 twice, and I've got the a to put in there as well. Minus 2 goes into 6 3 times. So 2a minus 3. And now we're looking to solve. So we need to do the first one. We need to expand it. Then we need to get rid of everything apart from x, and then solve for x. So let's expand first. 2 times 5x gives me 10x. 2 times negative 4 gives me negative 8. That gives me 21. Next line of working, try and get rid of the 8. So do the opposite. Plus 8 makes that disappear. And remember, we want it over there, so we've got to do it to both sides. So 21 plus 8 gives me 29. So 10 lots of x equals 29. And divide down by the coefficient. That cancels down to being 1. Divide that by 10. 10 goes into 29. 2.9 times. So x equals 2.9. Okay. Now if I wanted to check that, I could use the calculator and say, so let's just change the colour there. And let's go 2 lots of 5. 2.9 minus 4 equals, and that should equal 21. So just putting that to calculator, 2 bracket 5 bracket 2.9 close bracket minus 4 close bracket equals. and that gives me 21. So we know my value is correct. Question 18. Change 1 meter squared into centimeters squared. Okay, very common mistake that happens on this one. Here's my square. That's 1 meter. That's 1 meter. Okay, 1 times 1 gives me 1 meter squared. Okay, now thinking about this in relation to centimeters, that's 100 centimeters long, and that's 100 centimeters wide. So this time I've got 100 times 100, which gives me 100 times 100 gives me 10,000. 10,000 centimeters squared. Okay, 10,000 centimeters squared. The most common thing is they get to 1 meter squared and they say that's 100 centimeters squared. It is not 100 centimeters squared. Okay, you've got to times it by 100 on this side and 100 on this side to turn it into centimeters squared. Question 19. The diagram shows 2 squares. Work out the area of the square shown shaded in the diagram. So we've got 2 squares. We want to know the area of this one here. Okay, so we're just going to zoom into one part of it. I'm not going to physically zoom in, but what we're going to do is we're going to solely look at this bit here. If we cut that bit away, okay, we know we've got a side of 3 centimeters, we know we've got a side of 5 centimeters, and we need to know that length to know the length of my square inside. So here's my right angle triangle. So we're thinking Pythagoras or trig. What do I know? I know that side's 3. I know that side's 5. I know 2 sides. I want to find the missing side. So I'm doing Pythagoras. A squared plus B squared equals C squared. That's my A. That's my B. Remember, my C is always the longest side. So 3 squared plus 5 squared equals C squared. 9 plus 25 equals C squared. So that's going to equal 34. Okay, so I need to know the square root of both sides. So C is going to equal the square root of 34. Okay, so let's go back up to my square. We know that's the square root of 34 because it's a square. That's the square root of 34. That's the square root of 34. And we now calculated that's the square root of 34. Remember, we want to work out the area. So we're going to do length. Length times width. And we've got the square root of 34 times the square root of 34. I'm going to put that into the calculator. Root 34 to come out of the square root times by root 34 equals, okay, and anything when it's times by itself, root 34 squared, in effect what it is, okay, the square will cancel the square root and my answer would be 34 centimeters squared. Okay, so 34 centimeters squared. Root 34 multiplied by root 34. I could write that slightly differently by saying root 34 times root 34 or root 34 all squared. Both would give me the same answer, and that's going to give me the value of 34 centimeters squared. Remember, it's area, so it's units squared. Question 20. Here are the heights in centimeters of 15 plants. We're going to have to do a stem and leaf diagram. Remember, for stem and leaf, we put 1 digit this side, okay, and 1 digit this side. So if we've got 2 digits, Okay, one's going to go one side, one's going to go the other. If it was in hundreds, we would have to put one digit this side. This is the important side. Okay, one digit this side, and then we would have to put 2 digits on the left hand side. Okay, so on this one, 15 plants, we've got 1 5. Is that the smallest? Yes, it is. So 1. What else have we got? 2, 3. We've got 20s and 30s. So that's going to give me 2. That's going to give me 3. So 15, 1 5. Put a comma. Look for the next smallest. We've got 17, then 18, then 19, then 19. 17, 18, 19, 19. So we've got 20. There's no other 20s. 22, 22. 25, 25. We've got 24, crafty 24 in there. Okay, this is why you need to also think about when you're doing this. You could do a non-ordered stem and leaf first, and then do an ordered stem and leaf underneath if you wanted to. So we've got 24, 25, 25. Okay, we've got one more, which is 28. And then we've got 32, 33, 35, 32, 33, 35. Now, at this point, always check, have we got 15 plants? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, we have. I'm happy with that. We now just need to have a key, and I would always take the first value you've got there as your key. So 1, line 5. So whatever your first value is, show it as a key in your stem and leaf. Okay. We've taken all the values, put them in, and we're going to then say this is 15, 17, 18, 19, 19, 20, 22, 22, 24, 25, 25, 28, 32, 33, 35. Okay, and that's how stem and leaf works. Question 21. I'm going to zoom out for this one so we can see the whole graph. Okay, the scatter graph shows information about the volume of traffic and the carbon monoxide level at a point on a road each day for 22 days. So we've got 22 points plotted on that graph. First one, it says, we'll check the graph for a start. Volume of traffic, we're going up in equal increments, 100 at a time. Number of cars, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've got the same increments on the left hand side going up in twos. So we're trying to understand how the graph works. Next one, it says 1 point is an outlier. There's 1 point that doesn't seem to belong in our data. And we can see this one lays away from the rest of the data. This is all collected around this sort of area here. Okay, this one is just a little bit of a standalone. So that's known as our outlier. Write down the coordinates of this point. So we're looking to see, well, my coordinates are 100 along the bottom and 18 up the y-axis. So 100, 18. So I'm just reading off the graph. 100, 18. That's where that point lays on my graph. For another day, 370 cars pass the point on the road. Estimate the carbon monoxide level for this day. So 370 cars pass. So we've got 310, 20, 30, 40, 50, 60, 70. 370 is going to lay there. Okay, so to be able to estimate it, I need a line of best fit. So I'm going to try and draw a line of best fit on my graph that gives me a good chance of saying whereabouts on that line of best fit would this point be. So we check the lowest piece of data. Okay, we check the highest piece of data, and we want a line of best fit. So we're going roughly in the middle of those lines. It doesn't have to start at 0. Okay, really key, it doesn't start at 0. We're just going to say, if we cut that in half in relation to that data, where would it more or less be? So we would say somewhere. Okay, we've got more points at the top of that line than we have at the bottom. Okay, so that's not quite where I want it. So let's start down here again. Okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're somewhere there. That's about where my line of best fit is going to be. Potentially, I'm going to draw a second line of best fit. So again, you get a little bit of leeway on this sort of question. So somewhere between those two lines, I would say, would be your acceptable line of best fit. Now, the key thing is when you come up from your point, we're coming up to that line of best fit there, and we're going to then come across to the y-axis. So we can see 12, that's 13 there. So we're about halfway between 13 and 14. So estimate it, 13.5 milligrams per meter cubed. Okay, if we use the black line, and this is again another real key thing, okay, it relies for you to use your line of best fit. So we're going to use the same line coming up, but this time we're going to carry on to the black line. Okay, then we're going to come along. Okay, so we're talking about 14.25 maybe. Okay, 14.3. So we could say anywhere between those 14.3, okay, and 13.5 would give you the correct answer. And you can see my x-axis is exactly in the same place. The difference that I'm looking at is the difference in this value here between those two lines of best fit. So anywhere between 14.5 14.25 sorry, and 13.5 would give you a good range to be acceptable for a line of best fit on this particular question. Now it depends on where the points are marked, depends on how that question, where your line of best fit goes. Okay, so on this one, that would be my advice on that one. Okay, now next page, same question. We've got a C part to the question. Because there is an outlier, there is no correlation, is what Alfie says. Is Alfie correct? You must give a reason. Okay, well, we can see from these points, generally they are all, as the cars increase, so does the level of carbon monoxide. So there is a link between the level of cars and the level of carbon monoxide. So we can see that there is a correlation between the two. Okay, ignore the outlier. Okay, because that might have been a misread by the machine, or they might have just plotted it in the wrong place. Could be human error. So we look for the rest of the data, ignoring the outlier, and we can see generally as the volume of traffic increases, the carbon monoxide level increases too. Okay, so it wants to know, you must give a reason for your answer. Is Alfie correct for a start? Well, there is no correlation. No, he is wrong, because as the number of cars increases, the level of carbon dioxide increases too. Okay, so you're looking to say something along the lines of, as one increases, the other one increases. If it was a negative correlation, as one increases, the other one decreases. Okay, so you're looking for to put in words a validation, tell them what's happening in that actual graph. As the volume of traffic increases, the carbon dioxide increases, and that's what we're looking for. Question 22. Natalie makes potato cakes in a restaurant. She mixes potatoes, cheese, and onion so we've got potatoes, cheese, onion in that order. 1, 2, 3. So the weight of potato, the weight of cheese, the weight of onion is 9 to 2 to 1. Natalie needs to make 6,000 grams of potato cakes. So it's got to equal 6,000 grams. 6,000 grams. Cheese costs £2.25 for 175 grams. Work out the cost of cheese needed to make 6,000 grams of potato cakes. So, on a question like this, we're going to look to add the parts together. So we've got 9 plus 2 plus 1 is going to give me 12. So each one of these particular mixes, let's say we're in grams, that equals 12 grams. How many 12s go into 6,000? So that's my first protocol. 6,000 divided by 12 equals 6,000 divided by 12 gives me 500 grams. Okay, so I can make 500 lots. I can make 500 lots of this mix. So I'm going to times this now by 500. That gives me 4,500 potato. Times this by 500. That gives me 1,000 grams of cheese. And I'm going to times this by 500. And that gives me 500 grams of onion. If we work it all out, 4,500 plus 1,000 gives me 5,500 plus 500. That does now equal 6,000 grams. Okay, then we're going to come back up to the part of the question where it says cheese costs $2.25 per 175 grams. So I need to say, well, we've got 1,000 grams of cheese, and it's at £1, 175 grams equals £2.25. Okay, £2.25 for 175 grams. So I now need to think with this question, I need to know how many lots of 175 do I need to multiply by £2.25. So £2.25 multiplied by 1,000 divided by 175. That's the calculation I want to find out. How many lots of 175 go into 1,000? And then I want to multiply that by 2.25. So I'm going to write down in my calculator exactly what's on the screen. 2.25 times fraction key 1,000 grams divided into blocks of 175. Okay, and that gives me 12.857142. Okay. Work out the cost of the cheese needed to make. We're in pounds, so we need it in pounds and pence because it doesn't go exactly. Okay, now just going to go back a step in the sense if we did 1,000 divided by 175, we would get 5.714285 lots of 175 grams. Doesn't go in exactly. Okay, 5 times 175 gives me 875. 6 times 175 gives me 1,050. Okay, so don't round this. Always go with the figures, the full figures. So if I was to use this one and I times that by 2.25, I would end up with the same figure, 12.857142. Okay, so 5 lots of 2 gives me 10, and then I want a quarter of 5. So that's where my 2.5 and a little bit more's come from. Okay, so both answers will give me the same thing. So I know it's going to give me £12, and I need to round this value here. So that 7 is going to round up. So that's going to give me 86 pence. So £12.86. Okay, so there will be 1 mark to round the value you've got up there. Okay, 1 mark to calculate how much cheese you want, and then a mark for 1,000 divided by 175 and times it by 225. Okay, so if you need to go back and have a check through that one again, there's quite a lot of working that's gone into that one. Add the number of parts, get 12, divide 6,000 by 12 to get 500 lots of each mix, times each ratio by 500 to find out how much cheese we need. 1,000 grams. Okay, divide the 1,000 grams by 175. That's going to give me 5.7 and some oddments. Times it by £2.25 each set of it. That's going to give me £12.85. And then remember, round that 7 up to 1286. Question 23. Okay, write 4.5 times 10 to the power of 5 as an ordinary number. Okay, so 4.5 times 10 to the power of 5 equals, type it into your calculator exactly as it is on the screen, and it gives you 450,000. Okay, 450,000. Write 0.007 in standard form. If you put 0.007 into your calculator, it stays as 7 over 1,000. Press SD, it will also go to 7 times 10 to the negative 3. Now, if your calculator doesn't do this, okay, and I'm going to just do these two first, 4.5 times 10 to the power of 5. Having a positive indice means that we're making that number bigger. We're timesing it by powers of 10. We're timesing it by 5 lots of powers of 10. So 4.5, we're going to go 1 lot, 2 lot, 3, 4, 5 lots. That's when my decimal point will move to. Fill in the gap with placeholders. And you can see you've got 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. So that's where that number's come from. Okay. Looking at the next one, 0.007. 0.007. Okay, my decimal point's there at the minute. In standard form, my number has to be between 1 and less than 10. So let's make that decimal point there. So that makes my number 7. How many places do I need to move it to get back where it started? 1, 2, 3. We're going this way, which is always negative. I'm making the number smaller. Okay, so my index becomes negative. Okay, so first and foremost, type into your calculator, it will tell you exactly what it is. Press SD twice. Okay, and it will get to the standard form value. Okay, the next one I'm going to do, I'm just going to type it into the calculator. 4.2 times 10 to the power of 3. 4.2 10 to the power of 3 plus 5.3 times 10 to the power of 2. That gives me 4730. Okay, now on this one, it doesn't actually put it in standard form for me in the calculator. Okay, so to the power of 3, just going to type it into the calculator again, plus 5.3 times 10 to the power of 2 equals 4730. Yeah, so what I would have to do is make it again between 1 and less than 10. Okay, so it's got to be less than 10. That's my number. It could be 1. It could just be 1 on its own, but my number has to be between 1 and less than 10. So to make this number at the top here, between 1 and less than 10, let's make it decimal point there. So that's going to give me 4.73. We don't write the 0. It's only whole numbers, integer numbers, that's not a 0. Okay. And then how many places will we need to bounce that decimal place out? Remember, we're going this way, so it's going to be a positive number. How many places will I need to bounce that out to get to where I started? 1, 2, 3 times 10 to the power of 3. And that would be my answer. Okay. Now, if the examiner can see 4730, you would get 1 mark on that, even without doing the standard form bit, because you've calculated it correctly. Okay. If you struggle to do this and you wanted to do each part individually, okay, you could do 4,200, you could do 530, and then add it together to give you 4730. And then we're going to go to put it into standard form. Okay, that's another option that you could do. Question 24. A water tank is empty, and Anil needs to fill the tank with 2,400 litres of water. So that's key information. The fact that it's empty is key information as well. Okay, and we're in litres. Company A supplies water at a rate of 8 litres for 8 litres in 1 minute 40 seconds. Company B supplies the water at a rate of 2.2 gallons per minute. So we're in litres and we're in gallons, two different measurements. Okay, per minute, 1 minute 40 seconds. So we're going to have some conversions in time to do here as well. We can do 1 gallon is equal to 4.54 litres. Company A would take more time to fill the tank than Company B would take to fill the tank. How much more time? So it's telling us that Company A would take more time, so that's going to be longer. So let's think what we've got. Company A, we're going to split this down and we'll do it in a logical fashion. 8 litres in 1 minute 40 seconds. Okay, we need 2,400 litres. So we've got 8 litres in 1 minute 40 seconds. How do I get from there to 2,400? Well, your easiest way is to say, take the bottom number, 2,400, and divide it by 8. That's a multiplication factor of 300. Okay, so I've done 2,400 divide by 8 gives me 300. And I'm going to times the same thing on that side. Okay, now to do this, I've got to think to do that in decimal, because minutes and seconds are in denominations of 60s. Okay, this isn't going to go well if I just do it into a calculator. So let's turn it into seconds. So that's going to take 60 seconds is a minute, plus the 40 seconds, that gives me 100 seconds. I could times that by 300 really easily. So times it by 300. Okay, it gives me 30,000 seconds. Right, now let's turn it back into minutes, because we need the answer in minutes correct to the nearest minute. So 30,000 divided by 60 gives me 500 minutes to fill that pool. So 2,400 goes into 30 minutes. Okay, much easier than don't fall into the trap of doing 1.4 times 300, because it won't work. 1.4 times 300 would give you 420 minutes. So that's the mistake they want you to make there. Okay, don't do that. Okay, let's do Company B. This time, 1 gallon is equating to 4.54 litres. So 4.54 litres. Remember, we need to go to 2,400 litres, and that's 1 gallon. So we need to work out how many gallons do we need. What's my multiplication factor? So again, take the 2,400 and divide by 4.54. 2,400 divided by 4.54 equals. That gives me 528.63433612 gallons equals 2,400 litres. Okay, so I'm going to use the whole value. I'm not going to round it at this stage. Okay, they supply it at 2.2 gallons per minute, so I'm going to take the value of 528.63433612, and I'm going to divide by 2.2. And that gives me 240.288346. We're in minutes. Okay. Final thing, we know that Company A takes more time. It wants to know how much more time. So I take my 500 and I take away 240 to the nearest minute. I can round that there. The 2 is going to round down. So take away the 240. That gives me 260 minutes. So my answer is 260 minutes. So think how we've worked through that question. There's a lot of different directions of work in there. Okay, so we've started with Company A. we're converting the time very easily as it worked out into 500 minutes. Okay, by breaking it down into seconds and then converting it from seconds into minutes. On company B, we had to convert the litres into gallons. So we found 528 gallons. Now, I will just say at this point, okay, 528 divided by 2.2 still gives me 240. Okay, so if we had have rounded it there, this time it wouldn't have made any difference to the answer. Okay, so 528 gallons. So we divided it by 2.2, that gives me 240.2 minutes. So we would say 240, and then we took them away from each other. 500, take away 240, gives me 260. Quite a lot of work for four marks. Okay, so let's have a look at the next question. So the first four terms of a Fibonacci sequence are A, 2A, 3A, 5A. The sum of the first five terms of this sequence is 228. Work out the value of A. So the first thing is Fibonacci, realizing that we add the two terms previous to make the next term. 2A plus 3A gives me 5A. So 3A plus 5A is going to give me 8A. So we've got 1, 2, 3, 4, 5. First, second, third, fourth, fifth term. Because it says the first five terms of this sequence equal 228. So I've got A plus 2A plus 3A plus 5A plus 8A equals 228. Now, because we've got all the same letter, we're just going to put them all in a bowl and see how many we've got. We've got 1A, then we add 2A, so that gives us 3. Then we add another 3A, that gives us 6. We add another 5A, that gives us 11. And then we add another 8A. 11 plus 8 gives me 19, lots of A. So let's check that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 19. 19A. And that's going to give me 228. So I've simplified the whole of that first piece of Fibonacci into one term. And I'm just going to divide now down by the coefficient. Divide the 19 through and divide 19 into there. So A equals 228 divided by 19. So A equals 12. Okay. A equals 12. Question 26. In a bag, there are only red counters, blue counters, green counters, and pink counters. A counter is going to be taken at random from the bag. The table shows the probabilities of taking a red counter or a blue counter. So we've got two things already filled in. Remember, all of these added together, these four things added together, would equal one whole one. Okay, probability is always out of 1. The probability of taking a green counter is 0.2 more than the probability of taking a pink counter. So the two things here, if we took a pink one, okay, that's going to be 0.2 less than taking a green one. So a green counter is 0.2 more than taking a pink counter. So let's see what we've got left. So we've got one takeaway, 0.05 plus 0.15. If we add those two together, we end up with 0.2. Okay, if we take that away, we end up with 0.8. So if we cut it in half, 0.4, 0.4. Remember, we want 0.2 more. So if I take 1 off the pink, oh, let's do this side. Let's say this one's pink, this one's green. Keep it in the same order as we've got at the top. Okay, we take 1 off the pink counter. Okay, that's going to give me 0.3. If I take that one and add it on to the green counter, that's going to give me 0.5. And you can see the difference between those two is 0.2. So green is going to be 0.5, pink is going to be 0.3. The gap between green is 0.2 more than taking a pink counter. So if I add 0.2 onto the pink, I end up getting the green one. Okay. So again, thinking about this, we've got 0.3, 0.5, that gives me 0.8. Blue gives me 0.95. Add the red, gives me one whole one. So if there are 18 blue counters in the bag, work out the total number of counters in the bag. Okay. So let's see what we know. We know that if there are 18 blue, that equals 0.15. Okay, we want to make it equal to one whole one. Okay, so if I can divide this by 0.15, I can find out what 0.01 is. Okay, so 18 divided by 0.15 gives me 120. Okay, times that by one whole one, there are 120 counters. Okay, so let's see if we can work that one out a different way. If that doesn't make sense how we've got to that one, we're just going to do that down here. So we've got red, blue, green, pink. Remember it was 0.05, 0.15, 0.5 and 0.3. So there are 18 in that one. Well, let's think of 0.05s. 0.05 times 3 gives me 0.15. Okay, so if I divide that by 3, 18 divided by 3 gives me 6 red counters. To get from blue to pink, I'm timesing it by 2. Times it by 2, 18 times by 2 gives me 36. Now 36 to get back to the 5, 0.5 from 0.3. Again, slightly more difficult to think about it, but if I can get down to 0.1, divide that by 3, that gives me 12. So 0.1 equals 12. Times 12 by 5 gives me 60. And if I add those together, 60 plus 36 plus 18 plus 6 gives me 120 counters. Okay, so all I'm doing with this one is dividing the number they tell me by the probability they give me. So 18 divided by 0.15. That's your easiest way. Okay, question 27. The diagram shows a sector. 0 is the center of the circle. P, Q, and R. Okay. The radius we can see to the outside of the circle is 8 centimeters. Work out the area of the shaded segment. So we just want to know the segment size. Okay. So if we think what we've got all told, we've got, that's a really bad circle, but you get the idea. We've got a circle going around there. Okay. We know the radius, so we can work out the area of the whole thing. So let's work out for a start this part of the area here for the whole thing. Okay, we've got 1/4 of a circle. So we're going to do pi times radius squared. The radius we know is 8. And remember, we've got 1/4 of a circle. Okay, so if we divide it by 4, that's going to give me the whole area that we've just done in yellow. Okay, so I'm going to take pi times 8 squared divided by 4 equals. And I'm going to leave it in terms of pi for now, because it'll be easier to use later in the calculator. So pi times 8 squared, 64 pi. We're going to divide that by 4. So that's going to give me 16 pi. So that's the area of that whole sector. We want just this bit here, this segment on the end here. Okay, so if we can find the area of the triangle and then subtract it, okay, so just to show it here, we've worked out the area of that bit. Okay, if we can now find the area of that, we know it's 8 high, we know it's 8 wide, and to find the area, we've got base times height divided by 2. Okay, and that's the area of my triangle. The base and height we already know, so we've got 8 times 8 divided by 2. 8 times 8 is 64, divided by 2 gives me 32 centimeters squared. And remember, we had 16 pi centimeters squared on my area of my circle, quarter of a circle. So I'm going to take the two away from each other. So I will end up with 16 pi take away 32 equals. So that's what I put into the calculator. 16 pi take away 32 equals 18.2654826. It wants it to 3 significant figures. So first, second, third. I'm going to round it to that point there. The 6 is going to make the digit in front round up by 1. So 18.3 centimeters squared, because we're dealing with area. Okay, so we found the area of the quarter of the circle, we find the area of the triangle, and then we subtract them away from each other to give me 18.3 centimeters squared. Okay. Last question. Sketch the graph of y equals 1 over x. Okay, this is one of the questions that you should hopefully know what the graph of y equals 1 over x is. It's an exponential graph that looks like that, and it also looks like that. Okay, so y equals 1 over x. So if we think about if y equals 1, okay, so when y equals 1, 1 divided by what equals 1? So x equals 1. So when y equals 1, x equals 1. What about when y equals 2? When x equals 2, sorry. Okay, well, 1 over 2, when y equals 2, okay, when x equals 2, y equals, when x equals 2, y equals a half. So when x equals 2, y equals a half. What about when x equals 3? Well, when x equals 3, y equals a third. It's a little bit lower down. So we could start by just plotting different points on there. When y equals 0, x equals 0, you can't do 1 divided by 0. It doesn't happen. It doesn't work. Okay, and the closer we get, the bigger the x value gets, the closer we get to the x-axis. So y equals 1 divided by 4. That's going to give me a quarter. What about y equals 1 divided by x equals 8? If we was right over here, okay, still not going to get down to the x value, but it's going to get very, very close. But what about if x equals minus 3? What does x equal? What does y equal when x equals minus 3? Okay, well, 1 divided by minus 3, that's what y equals, minus 1/3. Minus 1/3. That's where my value is going to be. 1 divided by -1. Y is going to equal -1. So again, we're talking this point here when x equals -1, y equals -1. Okay. So there is a way to calculate it by just putting the x value into the sum of where we are, and then just trying to plot the points. So if we just erase off what we've got here and just look at that plotting point, if we've got time at the end of you've come to this question, you've got a little bit of time to plot it. Okay, to left. So what does y equal when x equals 2? Well, y equals a half. Let's say we've got 1, 2, 3, -1, -2, -3, 1, 2, 3, 1, 2, 3. Okay, so when x equals 2, y equals a half. That point there. What about when x equals 1? When x equals 1, y equals 1. We've got that point there. What about when x equals a half? Okay, 1 divided by a half. Well, how many halves can we get out of 1? Is going to equal 2. Y is going to equal 2. So that point there. So straight away, we're at a point. We've got 3 different points that we've plotted, and you've got your graph. Okay, and then you've got your graph this side. So anything like that will get you the points for sketch the graph of y equals 1/x. Okay. Well, like I say, hopefully you'll know that. That's known as an exponential. Okay, exponential graph, where that graph never touches 0. It tends to 0 each time on the x-axis, but it never actually ends up getting there. Okay, hopefully that was helpful, and good luck.